Students, welcome back. We'll be working today on the next property of exponents, which is the division property of exponents. So on the division property, many times things will be written as a fraction. And when you divide with powers, so in other words, an expression that has an exponent, you will keep the base and then subtract the exponents. And we'll do several examples to let you see how this works. So if you have 10 to the 5th power divided by 10 to the 3rd power, then we will keep the base of 10 and take those exponents, and it's always the numerator exponent minus the denominator exponent. And so your base will stay 10. 5 minus 3 will give us to the 2nd power. And then you can evaluate that. 10 to the 2nd power is 10 times 10, which would be 100. Now, just to show you why that works, 10 to the 5th is 10 times itself 5 times. And in your denominator, you have 10 to the 3rd, which is 10 times itself 3 times. And so you can cancel factors that are in the numerator and the denominator, and you end up just having 2. So in other words, the factor that had more tens was in your numerator, and there were 2 more than those in the denominator. So your exponent became a 2, 10 to the 2nd, which gave us 100. All right, let's try this again. Now, the 18 and the 6 do not have exponents. So 18 and 6 will reduce or divide with just regular division. So 18 divided by 6 is 3. And then your y's, you have 5. You have an exponent of 5 in the numerator, an exponent of 4 in the denominator. We're going to keep the base. Subtracting the 5 and the 4, we would get 1. And then in your denominator, we don't have a denominator anymore since everything actually divided out or canceled. Now, that is different from problem number 3 in the way that we've got our number parts arranged. Here, the larger number was in the numerator. So when we divided, the number stayed in the numerator. We didn't need to put a denominator, although if we did, it would be a 1. And then you could just have 3 to the 1st. But on this one, when you have 7 over 21, you're still dividing, but 21 divided by 7 is a 3, but it's in the denominator. So actually, you're reducing the fraction. 7 will go into 21 3 times. 7 will divide into itself once. And you actually have the fraction 1/3. And then we can take the a, which has an exponent of 6, and an a, which has an exponent of 1. Subtracting those exponents, 6 minus 1 would give you a to the 5th. Now, your b's, you have 3. You have b to the 3rd on the numerator and b to the 3rd in the denominator. And actually, those will cancel. And so you no longer have any b's at all in this expression. Now, 1a to the 5th, you could just write as a to the 5th over 3. So, as I did in that last part of the problem, you can think of this as canceling, thinking of it as there are more a's in the numerator than there are in the denominator by 5. So 6 minus 1 giving you the 5, and your answer would go in the numerator. Now that leads us to when you have negative exponents. So you can either have negative exponents happen because of subtracting the exponents, or sometimes an expression will start with a negative exponent. A negative exponent means that we will change the base to its reciprocal. So another way you may think of that is to flip it. So the a became 1 over a. That's the first change. And the second change is that we will make the exponent positive. So if you look at the rule here, we have a to the negative n equals, and then we made two changes. First of all, the reciprocal of the base became 1 over a, and then the exponent became a positive. So we'll take a look at these two expressions that have a negative exponent. The first one is 2 to the negative 4 power. So we're going to take our base, which is 2, and write it as a reciprocal. Now, one thing that maybe would help anytime you have a negative exponent, if you'll write that as a fraction. So if it isn't a fraction, write it as a fraction. If it's in the numerator, it moves to the denominator. So the 2 is going to move to the denominator. And when it does, your let's see, let me change colors. Your 2 is going to move to the denominator. And when it does, your exponent's going to move with it, only become a positive. Now, you cannot have a denominator without a numerator. So the 1 would actually be the numerator of that expression. And then 1 over 2 to the 4th. 2 to the 4th is 16, and this becomes 1 over 16. In the case of something that already is a fraction, you can do the reciprocal of that fraction. So 3 over 5 could become 5 over 3. Or actually, another good first move that I like to have students do is to remove the parentheses. So that's how I'm going to handle this one. We're going to remove the parentheses. So the 3 will get the negative 2 power. This is like last time's lesson. And in the denominator, the 5 base will also be affected by the negative 2. So the negative 2 power distributes to both of these factors inside the parentheses. And then if we have a negative exponent, it's going to move from wherever it is to another location. So 3 is in the numerator. We're going to move it to the denominator. And when we do, we're going to make the exponent a positive. Likewise, the 5, when we have the 5 in the denominator with a negative exponent, moves to the numerator. And when it does, it becomes a positive exponent. Then you can simplify. So 5 to the second power is 25. On the bottom, 3 to the second power is 9. And you end up then with the expression 25 over 9. Okay, we have another type of exponent called a zero exponent. When an exponent is 0, you remove the entire expression and you replace it with 1. So a number to the 0 power, or a variable to the 0 power, becomes 1. So 5 to the 0 power is 1. Now, if there are other parts to your expression, they stay. So you would have x to the fourth in the numerator, 3 in the denominator, but your y to the 0 would become a 1. And x to the fourth times 1 is just x to the fourth. And then the denominator 3. And then finally, we have just some expressions to simplify. So taking a look at your 8 over 40, that reduces. Now, it is true that 40 divides by 8, but that is in the denominator, so it has to stay there. 8 divides by 8 and gives you a 1. Then for your x's, you can subtract those exponents, but if you look where your larger amount of exponents would be, that's where you put your answer. So if you have x to the 7th and x to the 3rd, you're going to subtract 7 minus 3 and get x to the 4th power, but we're going to put it in the denominator because that's where the bigger amount was. And then we have y to the 2nd and y to the 5th. Again, I can take 5 minus 2 to get a 3, so I know I'm going to have y to the 3rd. My bigger amount is in the denominator, so I'm going to put my y to the 3rd in the denominator. And that would be then my final answer. Okay, now if you have an expression that has a negative exponent in it, then before we do any other work, we're going to move that expression from its current location to the opposite, to its reciprocal place. So I'm going to keep the numerator as is, just rewriting it. And part of the denominator, the 25, and the b, I'm going to leave alone. But this a to the negative 2 power is in the denominator. It's going to need to move to the numerator. And when it does, the exponent becomes a positive. So then I'm going to look to see, can I cancel or do any reducing? Well, 25 will divide by 5 and give me a 5. 5 will divide by 5 and give me a 1. So I know I'm going to have a fraction with 1 in the numerator and 5 in the denominator. I have a's on top. I have a 4 and a 2. So the a is going to total up. Those exponents are going to add to give me a to the 6th. And then I have b's. I have a numerator of 6 and a denominator of 1 for my exponent. So I'm going to subtract and I'll get b to the 5th. My larger amount of b's is in the numerator, and so that is where my answer will go. So it'll be b to the 5th in the numerator. And that will be then my final answer, 1a to the 6th, b to the 5th over 5. Your homework today is a worksheet, and then you'll have a Google form to complete. It's actually where you're going to choose your answer from an answer bank. And then at the end, if you've missed any, we want you to go back in and make corrections. So you'll complete the Google form until you get your answers correct. So be sure that you ask questions when you have them, and good luck on your homework.